Hello, welcome to this episode. In this video, I'm going to tell you a little bit about Lambda scaling. It's pretty different to scaling of servers, and hopefully I'm going to dispel some myths today. And to do that, I actually created this website. So this website is a Lambda simulator. So if you're a bit fearful about Lambda and not sure what to expect, this is a really cool resource that you can use to kind of understand what's going to be happening with your code base as requests come in. So if we had a general purpose server, we might have an application server running with a set number of threads, say 100 threads. And when those threads were consumed, we would have a pause while it waited for an open thread, or we would auto scale horizontally and wait for another server to be added to the cluster. With Lambda, it's pretty different. Each execution of a request happens in a single execution context. So you can think of each execution as single threaded, having its own dedicated virtual machine. This is great for security, by the way. But it means that when we need a new execution environment, there's a bit of extra work that needs to be done in order to provision that extra micro VM. This is called a cold start, and it's a little bit of extra tax that's required every time you do that small incremental scaling operation. So let me show you this tool that I made, and we'll start looking at some of the examples. Okay, so let's start super simple: 1 request a second, execution time of 1 second, and a cold start of 1 second. Let's see what happens. So an execution environment warms up and starts processing messages. Now I've set this simulator to be quite aggressive with the shutting down of environments. So an environment will shut down after 7 seconds of idle use. In reality, this is a lot longer, but just for demo purposes, I've put it quite aggressive here so I can show you what happens. Okay, so at this steady rate of requests, we don't add more environments, we don't lose more environments, but we have 2 working environments that are ready to serve requests whenever one comes in, and it just kind of flip-flops between the 2 different environments. Okay, if I increase the rate of requests that comes in, then I'm going to have these cold starts while I build up enough environments to process these requests. So I'm going to have additional cold starts. My 2 execution environments aren't enough, and I need more. So the Lambda service will automatically generate those execution environments and provision them. And again, now I'm in a steady state. If I lower the requests per second, I'm going to see that some of my execution environments become idle, and then after 7 seconds, we're going to see them shut down. And again, in reality, this would take a lot longer, can take hours, but it's non-deterministic. There isn't a set period of time that idle environments stay around for. Okay, so let's see what happens if I bump up the execution time. So I'm still on 2 requests a second. If I double it to 2 seconds for each execution, again, I'm going to get more execution environments, which means I need to warm up more execution environments. This is because I just have more concurrency. Now I've got a concurrency of effectively 4, so I need 4 working environments to handle the same load. Okay, so let's have a look at the effect of cold starts. So if I increase my cold starts to 2 seconds, then every time I need a new environment, it's just going to take a bit longer. Let's start with a new example. Let's start with execution time of 1 second, 2 second cold start, and a 2 requests a second simulation. Now you'll see that there are more environments going to be added because each execution environment just takes that much longer to create. But once they get into a steady state, it's fine. I don't need any more environments, and they're going to get shut down just in the same way. But if I get a burst of requests, I'm going to see that I need more environments, and each environment is going to take longer because my cold starts are longer. So I'm going to have more execution environments to handle the the same amount of load. I hope this has been really useful for you. If you've enjoyed it, please give this video a like and a subscribe. And if you want to know more about Lambda and how to build Java applications on Lambda, I've got a book available. It's currently heavily discounted because I'm still writing a lot of the content, but there's some really interesting stuff in there, and I hope that you'll enjoy it and give me some good feedback. Thank you.